So this video is optional. This is the activity that goes along with section 5.2. And remember, the activity is optional, but I strongly encourage you to do it. So this is about the addition rule, which is what section 5.2 is about. So we collected data from a survey of single-child households. The data collected was the sex of the child and the type of pet in the household. So we have these cartoon images, and normally I print these out in class for you. So blue ones mean that the child in the house is a boy, and pink ones mean that the child in the house is a girl. And normally, if we're in class, I give you guys paper cutouts, and you guys can do it that way. But what I'm going to do is, instead of using the cutouts, I'm going to use a blue C So blue C means cat in a boy household, with a boy child anyway. And I use red for cat with a girl child in the household. And we'll follow the same naming scheme, so we'll have blue D's and red D's for dogs. And for having both a cat and a dog in the house, I'll use B. I will use B for both of those. And remember, blue means for a boy, the child is a boy in the house, and blue means it's a girl. And for neither, those poor children with no pets, will use an N in both colors. So the first thing we need to do is cut out the provided cartoon images and attach them to the Venn diagram. So I will add the cutouts to this. I apparently have not done so yet. And let's make this a tad bit smaller. So here's our Venn diagram. And when I attach the files, you will see that we have three households with boys that own cats. So we'll put those right here. And we have 5 households with girl children who have cats only. Okay. For the households that have dogs, we have 6 households that have a boy child and only a dog for a pet. And we have 5 households with girls that have only a dog for a pet. Now, in the category where they have both a dog and a cat, we have 2 male children whose families have both a cat and a dog, and we have 3 female children whose families have both a cat and a dog. And then the poor sad children who have neither, we have 5 male children and 2 female children. So you can see I've made the Venn diagram here. If they own just a cat, remember they go in the cat circle, but outside where it overlaps with the dogs. Same thing with the dogs. If the family only has a dog, we put their data in the dog circle, but not where it overlaps with cat. Families that have both, they're the ones that go in this overlap that I'm sort of halfway shading yellow here. But remember, that covers the whole overlapped area. And then, of course, families that don't have either type of pet, well, those kids are in the sample space, which is our whole box, but they're not in either the cat circle or the dog circle because they don't have any pets. So now we're going to answer the questions by referring to this. And I'm sorry, we might have to do some scrolling up and down. Probably smarter, we should just, since I haven't printed this out, we should just maybe write down the data. So you can write down how many of what fall in each category. So let's go answer questions. I will scroll back up to the questions now. So, right now, it doesn't matter to us whether the child in the household is a boy or a girl. We're just going to worry about the type of pets. So first, we need to know what the sample size is. Well, that's simple enough. If we just scroll down again, all we have to do is count the number of things we have in here. So let's see, we have, and I'm going to put a little check mark by each one because otherwise I might count something twice. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So we have 31 total households. So our sample size is 31. So what's the probability that a randomly selected household owns a cat? So we go back down to count those. We have 1, 2, 3, 4, 5, 6, 7, 8 that are in the cat part, but we still have to count the households that have both a cat and a dog because they own a cat. So we have 8 and then 5 more in the yellow section. So that's 13. So remember, the probability is the number of things in the category we want. So owning a cat, that's 13 out of the total of 31. And you can convert that to a decimal if you want. I'm just going to leave it a fraction. So what's the probability that the household owns a dog? Okay, same thing. We have to count all the households that own only a dog, plus the ones in the yellow area that own both a cat and a dog because they own a dog. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 in the only dog category, plus 5 more in the both category for a total of 16. So the probability that a randomly selected household owns a dog is the 16 households that have dogs divided by the 31 total households. So what's the probability they own both a cat and a dog? Remember, the and indicates that it's in that yellow region that we shaded where the two overlap. So I believe we had 5 in that category. Let's go check. We do indeed have 5 households in the yellow category. So that means the cat and a dog is 5 out of 31. Now remember, or means, and this is probably something I should have said before, but another way to interpret or, so if we have option number 1 or option number 2, that means either number 1 happens and not number 2, or the other way around, number 2 happens and not number 1, or both number 1 and number 2 happened. So if I said I had peas or carrots for dinner, that means one of 3 things happened. Either I had peas and not carrots, or I had carrots but not peas, or I had both carrots and peas. And that's a little bit different than how we use the word or in everyday English. Normally when we say or, we mean one thing happened or the other thing happened, but not both. So if we go here and we need to find the probability that a randomly selected household owns a cat or a dog, we need to count all the cat households and all the dog households without counting anything twice. And remember, the things we're in danger of counting twice are those things in that yellow section where the family owns both a cat and a dog. So we can either count how many total households we have within our circles, or we can use the formula. So let's start just by counting, and then we'll do the formulas and we'll see if we come out to be the same thing. So cat or dog, remember, means cat only, dog only, or both. So we need to count everything that's within the circles. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we have 24 total households that have a cat, a dog, or both. So the probability would be 24 over 31. Now remember, we could have gotten that same number by using the formula that says the probability of cat or, sorry, I should write those out since we're using C or D for, so probability of cat or dog equals probability of cat plus the probability of dog, both things we've already calculated, plus, sorry, not plus, minus the probability of cat and dog. And remember, that part is the overlap. So I have run out of time for this video. I will pick back up with finishing that formula and continuing on in the next video.